Welcome to Unit 2. This unit is all about logic and proof. We're starting the first lesson on inductive and deductive reasoning. So let's look at the difference between the two. Inductive reasoning is based on observations and past experiences, while deductive reasoning is based on facts, definitions, postulates, properties, and theorems. This is probably the best way to distinguish whether you're dealing with inductive or deductive reasoning, whether you're basing this on things that you've observed or facts, things that you know to be true. Another difference between inductive and deductive reasoning is the direction that it moves. Inductive reasoning moves from specific observations to create a general rule, whereas deductive reasoning moves from a rule to a specific result. The different types of reasoning are used in different ways as well. Inductive reasoning is useful in coming up with a conjecture or hypothesis, essentially a guess, whereas deductive reasoning is useful in proving conjectures. The two types of reasoning used together can be very powerful. One thing to be careful with, though, is inductive reasoning does not always lead to a valid conjecture. It's possible just not to have enough information. Whereas given true assumptions, your deductive reasoning will always lead to a valid conclusion. Now let's move on and see if we understand the difference between inductive and deductive reasoning. Take a few minutes and read over each of the 5 situations that you see on your page. Decide whether you believe it's inductive or deductive reasoning. Commit to an answer, write inductive or deductive. We will go over them. You'll have a chance to change your answer, but this will be more effective if you've decided what you believe it to be. The first situation will be inductive reasoning. The big tip-off on that is the word that you have observed, okay? You have observed that for the last 5 or 6 weeks they've served cookies. So you assume that that's going to continue. That doesn't mean they have to, but that's a pretty good assumption. The next example is deductive reasoning. And the reason here is that you know for certain that you have an A- or better. Your lowest test grade is a 90. And so all of your grades being A- or better means you can't possibly have an average that's below an A-. That makes this deductive. This is deductive because your tire is at 40 psi, the maximum tire pressure is 35. Since 40 is more than 35, clearly your tire is overinflated. Again, you are making a conclusion based on past experience. In past experience, they're winning in less than 4 games. You're going to conclude, therefore, that their next game would also be less than 4 games, but it's possible that that may not be true. This is inductive reasoning. The last one is also deductive reasoning. One answer is 0.4, the second answer is 2/5. Those are exactly the same answer, therefore they are both correct. For the next set of questions, I want you to read through and decide what you can conclude. Think very carefully about each thing, and remember that you're not allowed to add information that's not stated. Stop the video, read the first example, and decide what you can conclude. In this situation, you should be able to conclude that Cass shoots a basket. The problem tells us that every time Caroline passes the ball to Julie, Julie passes the ball to Cass, and Cass shoots a basket. So if we know that Caroline passes the ball to Julie, we also know that Julie will pass the ball to Cass, and Cass will shoot a basket. Now stop the video, read the next situation, and decide what you can conclude. In this case, you can conclude absolutely nothing. It's possible that Susan bought the books at North Point Bookstore, but it's also possible she could have bought the books somewhere else. So there's nothing that you can actually conclude in this case. Once again, I want you to stop the video, read through the next situation, and answer the question that says, why is this faulty reasoning? Hopefully something to the lines of, simply because Karen doesn't have red hair does not mean that she doesn't sunburn easily. People without red hair could also sunburn easily. Also, even if she doesn't sunburn easily, this doesn't mean that she doesn't wear sunscreen. So we can't, this is an example of reasoning that doesn't hold true. Now let's take a minute to talk about true-false statements. A statement is considered to be true if it is true for all cases, every single one. A statement is considered false if it is false for at least one case. It could be true almost all the time. If it's false even one time, the whole statement is false. A counterexample is an example that proves a statement to be false. Use the parts of the word to help you remember what that means. Counter means opposite, so we're talking about an opposite example. It proves that it's not true. Now let's practice finding some counterexamples. Our conditional statement says if a shape is a quadrilateral, then it is a rectangle. A quadrilateral simply has 4 sides. So if I draw any 4-sided figure, now let's make this even more dramatic. Let's say I draw something like this. This is clearly not a rectangle, but it is a quadrilateral. That makes this statement false. Let's look at the next one. If an animal has 2 arms, then it is a human. Think about this for a minute. See if you can come up with an animal that has 2 arms that isn't a human. Come up with your own counterexample. Now let's take an absolute statement like any 4-legged piece of furniture is a table. We're going to separate this and write it as a conditional using if and then come up with a counterexample. Written as a conditional, we could say if a piece of furniture is 4-legged, then it is a table. So this is not true because we can come up with other 4-legged pieces of furniture. For example, a chair or a desk or any other piece of furniture that has 4 legs and isn't a table. Try the next one on your own. You should have something like, if a thing is a book, then it teaches arithmetic. Lots of counterexamples here. History books, English books, novels, all sorts of things. Now you try and write your own conditionals and counterexamples. These should be completed when we check your notes. Okay, let's see how well you understand true-false statements. Go through the statements on this page and list whether you believe they're true or false. Stop the video, complete the whole page, and we will spot check these. When we check your books, these should all be complete. Let's look at these. The first one, using the distributive property, we would get 4x minus 12. Since we have the same thing on both sides, always, this would be true. Let's get down to the statement about Dallas being in Texas. Other states have cities named Dallas. For example, there is a Dallas in Georgia. So Dallas, Georgia would be a counterexample making this statement false. Answer the other 3 on your own and start your level 1, your tier 1 assignment. Good luck. Remember that you should be completing your tier 1 assignment as many times as it takes to get those up to 100 and then move on to your knowledge check.